welcome to Brassic Classics, video number 3 of the restoration of the Fiat 500. Today, me and my friend Dave, who's over there, but doesn't want to be in the video, I don't know, are going to start taking off panels and working out what needs to be removed, what can be plated, and where to go from here. So we're going to work out what we're going to do, and then I shall take some more video. We're also going to do some welding practice. We're going to do butt weld, plug welds, lots of welds, and I'm going to learn lots of good stuff. Anyway, here we go. Okay, so today we are going to be welding using a MIG welder. Dave, what's that stand for?
Metal inert gas.
He knows his stuff. Okay, so we're going to do some practice welds on the old Sill. Well, I say the old Sill, I mean the new Sill that came off in the last video. What we need, grinder with a flat disc. I'm just going to clean this up like this bit here, and then we'll be ready to do some welding. Okay, so there's our panel, nice and clean, all good. Now also we need to put the earth on. We'll clamp to there. Let the fun commence. Oh, by the way, we're using a Hawk MIG 130, which is basically the cheapest gasless MIG I could find, because I had no idea what I was doing. We'll do a video in a second on how to set this up. Good news, Dave's agreed to be in the video to explain how the mask works. Dave.
Okay, you've got a self-tinting welding mask. Now these are great. We didn't have these years ago and it made welding a real pain. But now they've got a detector panel in the front. When it sees the spark from the weld, it auto tints, which means it goes from being able to see through it, albeit green, it then tints itself and it stops you obviously getting arc eye, which hurts.
So look in the mask, so let's see what different settings we've got.
Inside the mask, you've got a sensitivity setting and a delay setting. The sensitivity setting does what it says on the tin. It depends, it's how sensitive the mask is to the flash of light. Some welders set them up in different ways, and there's also a delay in how quickly it goes from being tinted back to being able to be seen through. And on the side there, you've got the shade control. You can go from 9, which is a little darker than it would be to see through, all the way around to 13, and there is a grinding setting for welders who don't want to have to take their mask off.
So what would you set this up for, Dave? How would you set this up for what we're about to do?
It depends, it all depends on the welder really. It's personal preference.
Okay. Well, how would you set it up?
How would I set it up? I generally set the shade to about 11. The sensitivity
is it about
roughly about 10 o'clock. About 10 o'clock. And again, delay in between sort of 12 and 1 o'clock. But again, that's a personal preference for me as somebody who's been welding since he was old enough to pick up the torch, basically. But yeah, these are invaluable.
Cheap as well.
And cheap. They weren't when they first came out. They were horrifically expensive.
I mean, it's just a cheap one off eBay that I got.
But again,
but it does the job
for your hobby welder or hobby mechanic, cracking bit of kit.
Next thing, how would we set the welder up for this?
The welder takes a little bit of setting up because, just pop that down there. The welder takes a little bit of setting up because different power settings are there for different thicknesses of metal. You've got a wire speed control, which is how fast or slow the wire comes out at the end of the welder, and that depends on how thick a metal you're welding, how you know, there's so many different ways, but 90% of welding is setting the welder up and having clean metal. Without clean metal and the welder set up properly, you're wasting your time. You're never going to get a decent weld. So it's worth getting some metal of a similar gauge, spend some time, play with the welder, get comfortable with it. There's no hard and fast rule to welding. It's practice, practice, practice. The same with anything else in the world. If you want to get good at it, you practice.
Okay, so we've got the welder set up. We've got wire speed on 2. Got it on the minimum heat because we're only doing a bit of 2mm plate, and we've got it on heat setting 1. So it's quite low. We're all sorted out. Dave, you got your health and safety gear on?
Well, I've got a pair of gloves and a welding mask on, and the musician's got his baking gear on. So that's the difference.
Dave's going to do some welding.
Somebody who can weld and a musician.
Dave's going to do some welding. I'm going to go get my cake out of the oven. Thank you very much. Okay, so we've just done our first little bit, and the only problem with these gasless MIGs, especially this one, is it's not very adjustable. We've only got sort of 2 settings for heat and power, and the only real adjustable setting is the wire speed. Dave, what are we looking at here, mate?
What you're looking at is a scenario where, again, like you said, it's not the most expensive welder in the world. It serves a purpose, but if you're going to get a decent weld, you need something
finer things. This is a little bit limited.
Finer tuning on the power settings.
Let's have a quick look at that. So what's happened here, Dave?
So what we've ended up with is I basically held the torch in the same place for too long, and we've burnt a hole through it. But on the other side of the panel, where the welds haven't burnt through, is you can see clearly there that the weld has penetrated right the way through.
That's good.
The piece of metal. With the best will in the world, you can get 2 pieces of metal, stick them together, put a weld down it. Yes, the 2 pieces of metal are joined together, but if you flip it over and there's no penetration mark, there's no burn through mark on the other side, you've not fused the 2 pieces of steel together. You effectively, all you've done is glued them together.
So you've got, if you don't have penetration, you have a weak weld.
Exactly.
Cool. Okay, so we've just done this weld. Dave?
We've done the weld down there. Again, it's difficult. I can't run a continuous seam of weld because it's just burning through the metal. We're using 1mm fluxed wire, which again, on fairly light gauge steel, you have to put a lot of heat through the wire in order to get it to initially melt. So when you're welding something like 2mm steel, ideally you want 0.6 wire. This is 1mm. It's a little bit heavy gauge. But if we look at the weld we've just done, the difference between a non-gas MIG welder and a gas MIG welder. On a gas MIG welder, you wouldn't have this oxidisation in the weld because the inert gas would expel any oxygen from around the weld, and again, oxygen has a certain amount of water and moisture in it, which creates oxidisation, which in turn will create corrosion. So an inert, a gas welder will always trump over a non-gas for the very simple reason you get a better quality weld and you don't get the oxidisation with it initially. You can see where almost instantly that's got some oxidisation in it. But if we turn it over, what we have successfully achieved is a nice smooth run of penetration through the steel.
Okay, right, now it's my turn to do some welding. I'm welding in Reeboks because apparently, Dave,
welding in £14 Primark trainers, it's not a good idea. The welding wire burns through and actually burns your foot.
Who'd have thought that? Who'd have thought that? Anyway, I'm going to do some welding. I've got a slight problem. I've got gauntlets. I've also got a slightly broken finger, so you can see the problem with it anyway. And oh, by the way, when I show you the welding, we'll say whose is whose. I don't, I'm not sure we'll need to say whose is whose. We can just look at it and just anyway.
Just do a like I've done there. Just do a nice straight run. Next to it. Go.
Okay, so bring it in and have a look. Okay, so looking at the welds, can you guess which one mine is? Mine is this one. Has penetrated, but Dave, explain what happened with mine.
The problem, I was watching your weld through the visor supplied with the Hawk MiG 130,
you mean the top quality visor?
Which is effectively is a piece of preformed plastic with, and it's good for watching an eclipse through. That's about as much use as it is. But I was watching Neil when he was welding the panel there. I mean, the weld itself, again, with the best will in the world, you're not working with the best equipment, and the wire is way too thick for what we're welding. But again, we're not going to make excuses.
Well, I don't know. I've got nothing against making excuses.
We're just going to run with what we've got, because a bad workman always blames his tools, but it's served me quite well over the years. The torch distance from where you're welding.
Let's have a look at this. Right, so
if you've got the torch out here, the wire is going to be continuously bouncing.
So this is why I ended up with about 1.5 inches worth of wire by the time I finished.
Yeah, by the time Neil finished, he had sort of roughly that much wire sticking out the end of the torch, which
is not good.
It's not ideal.
So I was basically too far away from your
workpiece. Yeah? Again,
let's snip that off.
Welding, I always like to snip. I don't like too much wire sticking out at the end of the.
So you've got about what, 10 mil there?
About roughly 10 mil.
Okay, cool.
And I generally tend to hold it, and it's always a good idea that when you're welding, to be comfortable, keep the lead of the welder as straight as possible, because remember that the wire is feeding through this from the welder to the end of the gun. So if you put
you've got curls,
a loop in it or anything like that, or you've trapped it with your foot or anything like that, it's going to restrict the flow of the wire through the gun, and that's going to affect your weld. It's going to affect your wire speed, your control, and that's again what 90% of welding about is prep work with it. This is actually ideal for welding sort of fairly heavy gauge stuff, because you've got 1 mil wire, the welder's on the minimum power setting,
and it's blowing
holes through sort of 2 mil steel. So ideally, again, this setup would be more suited to maybe welding the chassis legs up on a Land Rover, or
so what we're saying is it's fundamentally the complete opposite of what I originally said.
It is fundamentally the opposite of what you originally said. The wire for welding this gauge material, I would suggest using a 0.6, maybe a 0.8 at a push.
And a gas MIG.
And a gas MIG, because
far more control.
You cannot beat the weld you get when you use an inert gas. It displaces the oxygen around the weld. You get a better weld. It's proven. Nobody uses gasless MIGs in heavy industry, in the commercial sector. We all use gas MIGs. We all use anywhere between 0.8 and 1 mil wire, depending again on the gauge of the steel you're welding. So,
okay, great, cool. Okay, so me and Dave just had a closer look at the MIG and the feed for the wire. And Dave, what we found is that this wire, this welder isn't ever intended to run with 1 mil wire. We've taken the wire tension retainer off, and inside there's a small guide wheel. I'll do a close-up of all this in a minute so you can see. Now on one side it's got 0.8, on the other side it's got 0.6. So also it's a case of, I bought this, I've not done any welding before. If you happen to have a friend like Dave who's got welding experience, you'll save yourself months. Because I mean, this, I wouldn't have worked out this for months. It would take me a long time watching lots of different YouTube videos to find out, oh okay, this wire's far too thick for the job, and that's why I'm blowing holes and stuff. Whereas if you have a friend like Dave who's got all the experience, there you go, it's taken 2 seconds with there. Anyway.